recovery. And that's why not only backups, but actually having a restore strategy and having restore rule books is very important. And finally, the other objective we're trying to hit is the 3-to-1 rule, which is basically we need 3 copies of data, 2 in different media, 1 is offsite, and the final one is something that cloud providers don't want to give you. They're very reluctant of giving you an option to ship your automated snapshots, let's say from AWS to Azure. They don't even always give you option to ship it to a different zone or data center. So looking at Kubernetes specifically, what we've seen over the time is it's a very complex deployment. So we could have some data services outside of Kubernetes. We could have them in Kubernetes in dedicated namespaces. We could have them per microservice having their own data stores. And they can also have multiple data stores for the same application. So this whole complexity of deployment patterns means that, again, we can't rely on just the database be instrumented with the backups or restore scripts. We have to take it all together, and we have to write something that encapsulates your entire application. And that leads to a bunch of issues such as, okay, where do you run your scripts, right? If you have those, saying, oh, I want to back up this, I want to quiesce the application, and then do a database backup, and then maybe do PVC snapshots and so on. Where do you run it? How do you access the secrets? Do you have them? How do you trigger it, and so on? So, and on top of that is also, can I actually get the snapshots from whatever system I trigger for whatever system hosts them into this 1 in 3-to-1 into the offsite storage, which is not vulnerable to like system-wide failures. Also, when was my last backup for this application? And you might have, if you have them in all different systems, they're going to be at different time. They're going to be in different places. So getting all of this information together and actually being able to run them just like that, to run your recovery operation automatically, that's very important. So in order to deal with all this complexity, in order to address this whole things of configuring and running your scripts, rule books, or whatever you call them, so we created a project called Kanister. Oh, sorry. Yeah, and Kanister is a framework which is very simple, and at the same time it's very extensible by being very simple, which does management of this scripts that you can create. So the main, Kanister is the CNCF project. It's now in the CNCF space. The main components for it are custom resource definitions. So we talk in Kubernetes language in terms of APIs. There is a blueprint which defines workflows. So it defines how do you do things. There's action set which defines an operation that you perform, and it is a custom resource definition, and it traces the execution of the operation. So essentially your backup or restore operations are traced and retrievable from your etcd database, essentially with Kubernetes APIs. And finally, profile, which defines where data is stored. Essentially, it could point to S3, Azure, Google Cloud, and other object storage, S3 compatible object storage from third-party providers, and so on. And we have in our GitHub repo, we have some blueprints like a typical backup operations, which are more or less the same for everyone, for things like Postgres, MySQL, Elasticsearch, and so on. So that's something you can both take and just use, maybe modify the way that you access the secrets for it, and that's something you can contribute. That's something, if I write a backup script for some new vector database that doesn't exist there yet, you can contribute, and then everyone can use it. That's an open source part of it, which is very important. A bit of actual how all these components relate and how it actually works. Again, it's very simple structure. So we have a controller, which runs on Kubernetes. We have a blueprint, which is, again, either you pull it from an open source repo or you write it yourself. In the blueprint, you can organize how exactly for your application, for your namespace, for your deployment, what do you want to save and how it's going to back up. Then you create an action set as essentially a trigger to action, which will execute some pod with Kanister functions and actually save your data to the destination. If we go a little bit deeper into the blueprint, that's a core thing in defining your backup operations and restore operations, most importantly. It's a custom resource, so it's essentially a JSON stored in etcd, which you can represent as a YAML, and that's how it is represented in the repo, of course. It contains several layers of things, so it contains actions. In this blueprint example, we have backup action, we have restore action, we have delete action. Actions in themselves have one or more phases, essentially phases executed serially. So you may say an action to backup would be slow down or scale down your application, take a backup, scale application up, something like that. And we also have what we call defer action with, if backup fails, then defer will still scale your application up. So that's pretty simple kind of approach. So just execute several things in succession. Action sets themselves, also a bit of a note, I don't know how good is it? Okay, so you could see in the curly braces there, those are essentially template variables, and blueprints are templates for the operations, and essentially they could get the template values either from an object that you supply in the action set, or they can get it from options that you supply, or they can read a config map, or they can pull values from secrets in order to configure, let's say, access to the database that would pull values from secrets. So these are like templates for operations, and that also allows you to share them. So this is what we have in the GitHub repo. So there's no specifics there. There's no specific password or AWS credential in there, but you can pass it with these template variables. And the action sets actually filling up these template variables with the specific values. So they point into a specific config maps. They could point into specific secrets, and then Kanister will pull these config maps and the secrets and fill in the template variables in the blueprint. And also we have right, and also actions that technically can have multiple actions in them, which are going to be executed in parallel, while phases within actions defined in the blueprints executed serially. So there's a bit of a control on what happens in parallel, what happens sequentially when you execute them. Also, action sets they get updated by the Kanister controller. Kanister controller will track the operation and will update the action set with the status of what happened, when it happened, and what are the artifacts produced. So the action set as a resource will contain entire history of the operation execution and all the artifacts that have been created, given that blueprint gives that information out. And finally, the functions that exist currently in Kanister are roughly this set of things we can do. We can run a pod with a script, which is most common one, because it's very different APIs that we're dealing with, and different databases and different cloud providers. So the easiest way to do that is to delegate it to the blueprints, and yeah, you give us the script, we run it in pod. There's also some resource lifecycle, like create a resource, delete resource in Kubernetes, such as pods of deployments. There's some functions where you don't have to provide a script, and they already implemented in Kanister, such as backing up a file from, or a set of files directory from a PVC. So you want to just mount a PVC to pod and back up some files. This is already implemented as a function, so you don't have to write the script for that. CSI volume snapshot and some RDS operations. And there's basically a link to the docs which lists all the functions. And as a destination for the object storage, currently our tools that we ship, and that also out there in the repo open source, support a bunch of different object storages. And you can just create this profile resource which just says, use this object storage, and it will then ship to this object storage, and you can easily change them if you want to. And yeah, I want to do a little demo. I will try to do that live. I have my own internet. We'll see how that goes. I have a backup recording just in case. But this is what I'm trying to show in a demo. So I have my typical application setup. I have a database client application, and I have my database out in the outside of the Kubernetes cluster in some cloud provider, and I want to ship it outside of this. In this case, it's a S3 bucket for simplicity, but it might as well be like Google Object Storage or Azure Storage. And I'm gonna run Kanister in the same Kubernetes cluster as my database client. So let's try. Okay, is that big enough? Do I need to make it bigger? Okay, is that better? Okay, sorry. Right, so I'm just gonna copy paste some things I have prepared. So let's check what we have so far. And you can see that. Okay, you can see that. You'll see what I'm copying. So that's fine. That's fine. Let me get from the start. So what we have? Okay. I'll start with setting up. This is just a setup for my client, so I'll have a config map pointing to a database, which has database credentials. I have my deployment, which is my client, and I have a secret which is needed for Kanister to access RDS. So it's essentially AWS credentials to access RDS. If you run this on EKS, you can potentially do service accounts and make it and not have credentials. This way is just one way of doing that, because I'm actually running Kubernetes here on this machine. Then the next step, I just want to show what I have in AWS right now. And that's a moment of truth if internet works. Yeah, it does. Okay, so I have my RDS instance in US East 1, and I have my S3 bucket, and again, S3 is just for simplicity, because I just don't need to set up more stuff, but just to demonstrate that I'm shipping it outside, I have it in a different zone. So it's better than having it in the same zone as your database, but ideally you even want to ship it outside, different account, different cloud. Yeah, now let's go into our client and see we have a little database here with a bunch of apparently duplicated things in there, but we have some data. Yeah, we deal with some data. But just to check how many of them you have, I didn't clean up the data. Sorry, before that, I did run a demo back in the hotel. So 1, 2, 3, 4. I have 8 of them, four of which. Yeah, so we currently don't have Kanister installed in this cluster. So let's do that. Or maybe I forgot to delete it. No, it didn't exist. Now installed Kanister with just a single Helm install. Pretty straightforward, nothing special, nothing complicated. It's already there. It has a pod which runs the operator, and it has some CRDs installed, which are, as I was talking about, action sets, which are triggers for operations, blueprints, which are descriptions of operations, profiles, which are destinations, and this one you can ignore for now. Let's try to download more things from internet. So this one, we just grab a blueprint from examples from the public repo. Of course, you could download it and modify the YAML file, do your modifications, probably not point to internet when you're in your production environment, and actually look at what you're applying. But I'm just going to do that because why not? And now I have this blueprint. Let's look at the blueprint. Get blueprint. Yeah, and this is our blueprint, this big YAML, which describes actions. So let's say we have a backup action. It describes what kind of artifacts it will produce. It describes several phases. In this case, what we're trying to do in case of RDS, we create an RDS snapshot. Then we pull this snapshot out to S3 as a separate phase. Please, keep in mind that at this point, technically a snapshot is done, right? So this is an export phase, which is not necessarily contributing to our downtime if we want to add the downtime or interruption. And the final stage is just deleting the snapshot that we created because we shipped it out. We don't care for it to stay in RDS. We want to save some resources in RDS. And so restore application will just grab this exported snapshot and restore it to the database. So this is what we grabbed from open source repo. This is just a template, so you'll need to fill in later with the actual data. So let me clean the screen for a second. The next stage is, and that's the stage we need to do, is to configure where do we save. So we need to create a profile, and here I'm just giving it AWS credentials. I hide them in the environment variables just in case you want to steal them. But yeah, this scanCTL command It's a wrapper, essentially, for kubectl. All it does, it just creates a resource definition, and it sends it to the Kubernetes API. So nothing special. You can do exactly the same thing with just YAML if you feel like editing some YAML, or JSON if you into that. But this is just a helper which lets you configure things, set optional keys, and so on. And here, yeah, our S3 is US West. This is a bucket. And I'm creating this profile. Here we go. I have a profile. Expert. I will need to use this profile in the action set. That's why I'm saving its name. Yeah, and sure, we can take a look of what profile looks like in this case. So it has AWS S3 as a type. It has a bucket name in there, and it references a secret. So the actual credentials are in the secret. So if you use like secret store, you can store it there. So profile itself is just a configuration that's saying that this is an S3 profile. And finally, to perform an operation, and yeah, because I didn't clean up the data, there was 8 records there, just to remember. I'm also using CNCF to create an action set. Again, this is a wrapper over kubectl. We can do the same thing with just plain Kubernetes APIs. And I'm selecting the blueprint that I want to use. I'm selecting the action in the blueprint, which I want to use. I'm selecting the profile, and I'm pointing it to the config map. This could be something else. This could be a deployment. This could be stateful set. This could be a namespace. And then the blueprint will have a reference and access to that resource. Here's just the config map, just because we're just dealing with the database and not with the application. But if I reference the deployment, for example, and the config map, then it could slow down, like scale down the deployment, for example, and it will reference the deployment that you provide here in the action set. Also the region for RDS access to create snapshots, and the secret for RDS. So here's the action set. It's created in Kubernetes, so it could be Kanister, get. So let's see what happens there. This spec, essentially, is what gets created, and it's what you can do if you want to do it yourself without a helper tool. This is just specifying blueprint, action, a bunch of, this is a config map that you access and so on, and some additional properties and options for the blueprint that you have. And this is based on the blueprint that you have. So blueprint will have, let's say, template variable options. It means that you need to provide an option in the action set to fill it in. And the controller is currently running certain stages, and it will update when stages get updated. We can even watch yeah, we can even watch it's being updated. A little note to that is this particular action set takes a while. So we're not gonna sit and wait for, I mean, we have time, we could sit and wait, but for the purposes of time, we're not gonna sit and wait for this one to complete. But get action sets. Yeah, so I have a previous iteration of an action set, and I can pull this one, and this is how it would look like when it's complete. So essentially each stage will say it's complete, the action set itself will say it's complete, and it will essentially have the artifacts part in the status of the action set filled in with what artifacts it created. So now let's say if we go to S3 and we look at what we have in S3, and this is our artifacts for this already completed action set, which I did in the hotel just a few hours ago. So we have this, which means that if we have, and that's a bit of a note to the things I'm going to do, if we have the artifacts, if we have the blueprint, which have a restore action in there, and we have a profile to actually access these artifacts, we can create a restore action set. In this demo, I just going to create a restore action set out of backup action set to fill in all the information. But again, it can all be done manually or from, let's say, if you want to export your completed action sets into some other storage just to reference your artifacts. It's all up to you because it's all just text. So let me do some damage first, because why not? Rope table, am I using right? Yeah. Yeah, let's drop a table, because why not? No pets for you, okay. Okay, so what do we do? How do we recover from that? So let's grab the action set which actually completed, just because this one, the one that we're running right now, takes some time. So just export for convenience. And then CANCTL does have a helper function in the CLI to let you create an action set for restore from an action set to backup. Again, you can do that with editing YAML if you don't have this in your Kubernetes database. We don't have this backup ID action set in there, but here I have, so I can do that. I'm using profile ID, right, so this should work. Okay. Yeah, it's actually complete. It's way faster than backup because I'm not doing complicated export. I'm just grabbing whatever is in S3, and I'm not the restore operation in this case is not doing the RDS restore of a database. It's not creating new database instance. It's just restoring the data. And so if we let's say we grab the action set from this. This is our restore action set, which references artifacts. It references the blueprint and the action and the object that we passed. It doesn't reference the backup action set itself. It just grabs information from it. And it also describes the stages, when they were completed, what was the status, what was executed. And finally, yeah, let's get back to the database. And because of the way I did that, yeah, we don't have the 4 of them, because I guess what I've done there is I duplicated them accidentally, which is a thing that I did in this demo. So that's on me. But we do have a recovery from the previous backup. So yeah, this is pretty simple, pretty straightforward. We just run the scripts that we define in the blueprint. Kanister just takes an action when it's created, monitors it, updates the status, saves it in etcd essentially. It has blueprints that it reads the information from, and these are all the actions. Oh, I shouldn't have done that. Just this is all the action sets that are in progress or that are complete. So yeah, that concludes the demo. We could take a look at this one again, but it does take some time because of the specifics of this blueprint. You can do things differently, and you can define what do you want to do. So you define. So we have blueprints, for example, which allows you to do the file level backup of Postgres, for example, with PG backup stop start. We have blueprints which allow you to scale down and up the application. We have blueprints which interface with the cloud providers. Whatever you can do essentially with just running pods, you can do with Kanister, but what it gives you is this blueprint. This is how you do it. It all runs on Kubernetes, and you have access to any object storage as a destination for your data. So yeah, so essentially in this demo, what we did, we shipped RDS into object storage, shipped it outside of the zone, but it could be in a different object storage altogether, in different cloud. Everything run on Kubernetes runner, so you don't need to think of, where do I need developer machine? Do I need admin machine with permissions? Where do I get them from to run it? All the blueprints that been doing that are in your Kubernetes. They could be in your GitHub repo if you want to do GitOps there. And all the actions that are also in Kubernetes, so you can then potentially, if you want to pull them out and save them somewhere, or you just see them as a list of operations with timestamps and with exactly which steps were executed, at which point what artifacts they produced. So that lets you actually get this complexity and just organize it. It doesn't do anything magical, it just runs essentially what you tell it to run, but it does that. It does simplify the management of your backup and restore operations, and what's important, you can run a restore like that, right? You don't have to look at the doc saying, oh, we have backups of this in here and this in here, and then you need permissions and so on. So that's the big advantage, and also you can test things because it's easy to run. And yeah, finally, there's a GitHub repo, there's a Slack channel, there's a website. Here's where we have all the example blueprints for different databases. If you have a question, oh, does it support Mongo? It's there. Yeah, and if there's something that it doesn't support, well, feel free to write a blueprint because it's pretty straightforward. Like, what do you put in there, and put it in there. Make a PR.
Thank you very much. If anyone has questions, we'll go to the mic because we do have a live stream, so we make sure we get that. I have a first question, I think. You mentioned everything basically goes to object store. Is that a requirement if I'm doing this on-prem? If I have NFS or something else, I need to spin up min.io or have something in there to be able to dump this to object store?
Right. As a destination, we mostly have object store, but we also support NFS if you want to be your destination. So we have the, in Kanister, we have this command line tool which you can pipe your dump into, and then you tell it, with profile, you tell it where to save it, and it could be NFS, it could be object store, it could be, I think, file system as well if you mount it. So you have to like configure your blueprint to do that, but it is possible.
Cool. Any other questions?
And if it's not yet, make an issue.
Is this only for database backup only, or for any other thing also we can backup from Kubernetes?
Right. So we have, this example was using database and I was using the RDS special functions. We go back here. Do support CSI snapshots, do support the file level snapshots if you can. So you either need your PVC to be mountable, or if you can instrument your pods to have the Kanister tools, let's say as a sidecar container, you can then trigger the sidecar container and tell it, okay, now ship some files out. So yeah, files, CSI, snapshot, and then anything you can run in the pod. If you have a script on the API, AWS API, you can have a pod with AWS CLI and then do whatever. You can have your own pod with your own APIs in there. You run it, you put the command, what you want to execute. It executes it. There's no real limitation for that.
One more question. So when we are running JVM applications in Kubernetes, so if there is any memory leak issue, Kubernetes will automatically kill the pod. So we can add some flag to the JVM process saying that heap dump on out of memory error or something. So there's a flag. So it will heap dump it. But when the pod goes away, the volume that's there in the pod will also goes away. Is there any way we can back up those things in Kubernetes?
I think it is actually an example for scenario when you want to have the tools sidecar and your action sets would instruct. So here we say run pod with custom logic, but there's another function in the functions list which basically lets you exec into a running container, which could be the sidecar container. You exec into and execute a command in there, given that you give enough permissions to Kanister operator to do that, which can let you just, you have an action set to exec and just pull whatever you need to pull at this point. A bit of a caveat about Kanister is that it does not have the scheduling part, so you have to create an action set. You have to have your own whatever cron or other tools to actually create these resources in order to trigger your operations.
Thank you.
Anyone else? All right, thank you so much.
Thank you.